Question number 51. If the perimeter of the triangle is 20 and two of its vertices are given by -5, 0 and 6, 0, then the locus of the third vertex, which we have assumed to be h, k is. So basically in the question, you have to find out the locus of this point A. And I have assumed the coordinates for the point A to be h, k. Now you know one thing, the perimeter is 20. That means AB plus BC plus CA is equal to 20. You know BC, it's 11. So AB plus CA will be 9. Yeah, it will be equal to 9. Correct. Now, what is AB equal to? Let's apply the distance formula. AB is equal to root of h plus 5 square plus k square plus h minus 6 square plus k square is equal to 9. Right? Let's take this on the right hand side. You will have root of h plus 5, sorry, h plus 5 square plus k square is equal to 9 minus root of h minus 6 square plus k square. Let's do squaring the both sides. You will have, I'll open up the squares also. H square plus 10h plus 25 plus k square is equal to 81 plus h square minus 12h plus 36 plus k square minus 2 into 9 h minus 6 square plus k square. So here, one minute. Okay, this is equal to, and this h square and k square, h square and k square will get cancelled. You will get, this will be equal to 10h plus 25 minus 81 plus 12h minus 36 is equal to minus 18 root of h minus 6 square plus k square. Now let's solve. You will have this as 22h and I have this 81 and this, okay, this will be minus 92 is equal to minus 18 root of h minus 6 plus k square. To make it simpler, let's divide both the sides by 2. You will have 11h minus 46 is equal to 9 multiply root of this. Now let's again, here was minus 9. Yeah. Now let's again do squaring on both the sides. So you will have 81 into h square minus 12h plus 36 plus k square is equal to 121 h square minus 1012h plus 2116. This one solving will give you 81h square minus 121h square. This will be, let's open up the brackets first. 81h square minus, when you will solve this minus 121h square minus this whole thing, 81 into 12h plus 1012h plus 81 into 36 minus 2116 plus k square is equal to 0. So on solving this, you will get minus 40h square plus 40h plus 81. Here was, I missed 81 k square and minus 800 is equal to, sorry, plus 800 is equal to 0. I missed on writing one thing, minus 2, 1. Okay, fine. This is, I've written, sorry. So this thing will come out to be plus 800. Now multiplying both sides by minus 1, 40h square minus 40h minus 81k square minus 800 is equal to 0. There is nothing common in all of them. So that means this is the locus of the third vertex. Okay. And this is the answer to our question. Let's check with the options. I have option A as the correct answer. Hope you got that. Let's move to the next question. Let's write it down. Let's move to the next question, number 42. The transformed equation of 3x squared plus 4xy plus y squared minus 8x minus 4y minus 4 is equal to 0 is this when the origin is shifted to a new point by the translation of x's. Then you have to find out f of 1, 1. Okay. So now basically the center is at origin and it is shifted to some another point. Let origin be shifted to p comma q. Then this equation will be 3x plus p square, 4x plus p into y plus q plus y plus q square minus 8 into x plus p minus 4 into y plus q minus 4 is equal to 0. This gives you 3x square plus 4xy y square 6p 4q minus 8x plus 4p 2q minus 4y plus 3p square 4pq q square minus 8p minus 4q minus 4 is equal to 0. Now, this whole and these both are, because it was at origin, so these both are 0. So 6p plus 4q is equal to 8 or minus 8 is equal to 0 and 4p plus 2q is equal to 4. Let's solve them. You have 3p plus 2q is equal to 4 and 2p plus q is equal to 2. So 3p plus 2q is equal to 4. And let's multiply this with 2 and subtract. You have 4p plus 2q is equal to 4 minus minus minus. You will have p is 0. And when you will solve this, you will get the value of q to be equal to 2. Right? Now, in the question, it's given that fxy is equal to this. So, fxy over here, when I put p is equal to 0 and q is equal to 2 in this particular equation, you will get fxy is equal to 3x square plus 4xy plus y squared minus 8. And you have to find out f1 of 1. That means it's 3 plus 4 plus 1 minus 8. That's 0. So you have options A as the correct answer. Hope you got that. Let's move to the next question, number 43. So in this question, if the line 2x minus 3y is equal to 0 divides the line segment joining these 2 points in the ratio m is to n, then the point which divides AB in the ratio, then point which divides AB in the ratio minus 4m is to 3n is. Let's draw the line first. So now this is the graph for this problem. I have drawn this axis. This is the x and the y axis. Of course, you know this line represents 2x minus 3y is equal to 4. This is point A and B respectively. And this line is dividing these two lines in the ratio m is to n. All right. Now, according to the question, the ratio like m upon n, this can be written as 2 into minus 2 minus 3 into 3 plus 4. Whole divided by 2 into 3 minus 3 into minus 2 plus 4, which will give you on solving 9 upon 16. This is the value of m upon n, correct? We have to find out minus 4m upon 3n. So minus 4m upon 3n will be given by 9 into minus 4 upon 3 into 16. So this will cancel out and you will have your answer as minus 3 by 4. Now you have to find out what we have to find out, the point which divides the line in this ratio. Now the coordinates of this point will be given by, let the point be P. So P will have the coordinates as 3 into -3 minus 4 into -2. Wait. Into -2 whole divided by 3 minus 4. Next 3 multiply -2 minus 4 multiplied by 3. 3 minus 4. So this is equal to -9. Sorry, here is +3, not 3 into -3. Sorry, this is minus only. Okay. I'll redo this part. Now let's get back. Now the point P will be given by this coordinate 3 into 3. I'm taking 3 for this, or you can take -3 for here, plus 4 into -2. This is given by 3 minus 4. Question number 43, it says if the line 2x minus 3y plus 4 is equal to 0 divides the line segment which is joined by these 2 points. Let's draw it. So A represents the point -2, 3 and B represents the point 3, -2. Let's join. There's a line 2x minus 3y plus 4 is equal to 0, which divides this line segment AB in the ratio m is to n. You have to find out the ratio -4 is to 3n, -4m is to 3n. So if you have to find out, basically, if I get to find m upon n, then I can easily find out my required question, right? And you can find m upon n ratio. M upon n is given by minus of this 2 into -2 -3 into 3 plus 4 whole divided by 2 into 3 -3 into -2 plus 4. 2 into 3 minus 3 into -2 plus 4. This comes out to be -4 -9 plus 4 upon 6 plus 6 plus 4 whole negative. So this is equal to, this will cancel out and you will have 9 upon 16 as m is to n. And you had to find out -4 upon 3n. So -4 into 9 upon 3 into 16, you will have this -3/4. Let's see what we had to find out. Then the point which divides AB in this ratio. Okay, now AB, the point was -2, 3 and B point was 3, -2. And now the ratio is -3. Actually, this is dividing externally, okay? Yeah. So this is, I'll redraw it. Here is point A, which is -2, 3, and here is point B, which is 3, -2. So according to the question, this is 4, and there is an external point P, which is like this. Okay. So now this is 3. This is how the division is going to take place, and you have to find out the coordinates of this point P. Let's go. I'll apply the section formula for this. So let's go find out the P coordinates. This will be given by 3 into 3 minus 4, because it was -3/4, right? -4 into -2 upon 3 minus 4, comma, and here will be 3 multiply -2 minus 4 into 3 upon 3 minus 4. So this is equivalent to 9 plus 8, that is equal to 17. upon -1, and here is similarly -18 upon -1. So this point comes out to be -17 and 18. This is our answer. Let's check with the options. We have option A as the correct answer. Hope you understood. Next question number 44. If the lines L1, which is represented by this equation, L2 and L3 are congruent, then the cosine of the acute angle between L2 is equal to 0 and this line is given by. Okay, first thing, now according to the question, these three lines L1, L2 and L3, they are congruent. So that means the determinant, if I write them in the determinant form, so this is 2, 1, 3, K, 2, -3, 3, -2, and 1. The determinant is going to be 0. Let's find out the determinant. So 4, 2, this has got to be -6. -1 into K, minus plus 9, plus 3 into -2K minus 6. This is 0. This gives you -4. This is -8. And here is -K minus 9 minus 6K minus 18 is equal to 0. That gives you -7K, and 17 plus this gives you 35. So -35 is equal to 0. That gives you K is equal to -5. Correct? So now the L2 equation becomes L2 becomes -5x plus 2y minus 3 is equal to 0. Now, you have to find out cosine of the acute angle between L2 and 2x minus 5y plus 7 is equal to 0. So, another line, 2x minus 5y plus 7 is equal to 0. So, let theta be the angle between them. Okay, that means tangent of theta is given by the slope like m1 minus m2 upon 1 plus m1 into m2. So look at these two lines. What will the slope of this line L2? Okay, I'll solve it here. Slope L2 will be given by, it will be 2y is equal to 5x plus 3, or y is equal to 5 by 2x plus 3. That means the slope m1 is 5 by 2 in this case. And now 2x minus 5y plus 7 is equal to 0. You can write down 5y is equal to 2x plus 7. So here y is equal to 2 by 5x plus 7 by 5. Here was also by 2. Okay, so from here the slope is 2 by 5. So this is 2 by 5, 1 plus 5 by 2 into 2 by 5. 5 by 2 minus 2 by 5 upon LCM 10, 25 minus 4. This is 21 upon 10 into 1 upon 2. This gives you 21 upon 20. This is equal to the tangent of angle between them. Correct? So I got the two sides. The tangent between them is like 21 upon 20. Using the Pythagoras theorem, you will solve, this line will come out to be 29. I'm using the Pythagoras theorem. I hope you can easily do this thing. Correct? Okay. So now you have to find out the cos of angle between them. Cos is given by base upon hypotenuse. That means 20 upon 29. So this is the answer to our question. So option D stands to be the correct answer. Right? Easy question. Next, question number 45. If Q is the image of the point P11 with respect to the straight line x plus y plus 1 is equal to 0, then the length of perpendicular drawn from Q to this particular line is, okay, there's a bit correction in the question. Here is got to be x minus y plus 1 is equal to 0. This is the line instead of x plus y plus 1. Now, let's go with the solution. First thing, let's see. This is the point. Let this be the point 1, 1. And here is the line x minus y plus 1 is equal to 0. So Q stands to be the mirror image. Let the coordinates of Q be HK. You know, this distance is equal to this distance, right? So formula for image of a point from equation of the line. This is given by h minus, if I'm taking this as x and y, so h minus x upon a, where a is the coefficient. If I'm taking this as a general equation, a is the coefficient over here, is equal to k minus y. Why is this point upon the coefficient? Okay, I'll not take this x, y. Let's take this as p and q, because x, y you might confuse with these two alphabets. Okay, so this is p and this is q. All right, upon the coefficient of y is equal to minus 2 of ap plus bq plus c whole divided by a square plus b square. Correct? Now here h I have to find out. P was 1, a is also equal to 1. This is equal to k minus 1, b is minus 1 in this case. This is equal to minus 2, a into p is 1, b into q is minus 1, c is 1 in this case. See, from here, equation, a is the coefficient of x, so a is 1, b is the coefficient of y, minus 1, c is the constant, that is 1. Okay. All right. This is whole divided by 1 square plus 1 square. This gives you h minus 1 is equal to, so this will be cancelling out and this will also cancel and you will have minus 1, which gives you h is equal to 0, and k minus 1, actually negative of it, this is also equal to minus 1, which gives you k minus 1 is equal to 1, or k is equal to 2. Okay, so we got the point of coordinates of the image q. Image q has the coordinates as 0, 2. This is the image coordinates. What do we have to find out? Length of perpendicular drawn from q to this line. So here is the point q having the coordinate 0, 2. If I drop a perpendicular from q to the line, what was the line? 3x minus 4y plus 3 is equal to 0. So the length of perpendicular is given by mod of 3 into 0 minus 4 into 2 plus 3 whole divided by root of 3 square and 4 square mod. So this is 0 minus 8 plus 5 minus 5 and root of 9 plus 16, that is 25. It will give you 5 also. That means minus 1 mod will give you 1. So this is the length. That means option C is the correct answer. Hope you got that. Let's move to the next question. Question number 46. The centroid of the triangle formed by these lines is. Centroid, you know the formula. If I note the vertices of the triangle, see, these are the 3 equations given. If I come to know about the 3 vertices, I can easily find out the centroid. That is quite easy. But I am instead given 3 equations. If I have 3 equations, it's easy to find out 3 vertices, right? First 2 equations, this is number 1, number 2, and number 3. So let's pick up 1 and 2 equations from 1 and 2. This will be like x minus 3y plus 3 is equal to 0. X plus 3y plus 3 is equal to 0. So adding both of them, you will get to x plus 6 is equal to 0, or x is equal to minus 3. You will solve and get the value of y is equal to 0. So let's pick up this next equations 2 and 3. From 2 and 3. Here you have x plus 3y plus 3 is equal to 0. X plus y minus 1 is equal to 0. Minus minus plus. This will cancel out. And you will have 2y plus 4 is equal to 0. That gives you y is equal to minus 2. And on solving, you will get x is equal to 3. So, okay, this was the first point over here. The intersection point of these two lines was minus 3 comma 0. So let it be A. The second point is 3 comma minus 2. Now let's go to find out the third from 1 and 3. You get the lines equations were 1 and 3. Okay. X minus 3y plus 3 is equal to 0. X plus y minus 1 is equal to 0. Minus plus. Sorry. This is minus only. Minus minus plus. So these will cancel and you will have minus 4y plus 4 is equal to 0. That will give you y is equal to 1. And on solving, you will get x value as 0. So C point comes out to be 0, comma 1. So now A minus 3, comma 0. B was this. C is this. These are the three vertices of the triangle. So centroid, it's given by x1 plus x2 plus x3 upon 3. So minus 3 plus 3 plus 0 upon 3. And y1 plus y2 plus y3 is equal to 3. So 0 minus 2 plus 1 upon 3. That gives you this as the centroid of the triangle. 0, comma 1 minus 1 upon 3. That is option A. Hope you got that. Let's move to the next question, number 47. If the slope of one of the lines represented by this equation is 3, then angle between the pair of lines is given by. Okay, so one thing over here. First thing, you are given the pair of equation of the lines, that is 5x squared plus 40 upon 3xy plus ky square is equal to 0. You can write it as, so if I compare this as sum k into y upon x see, I'm dividing both sides by x square. So k into y upon x squared plus 40 upon 3 into y upon x plus 5 is equal to 0. So here the slope represents, slope is 3. So that means slope is given by y upon x. So this is equal to 3. So that means y upon x is equal to 3. Looking at that, this equation becomes 9k plus 40 plus 5 is equal to 0, which gives you 9k is equal to minus 45 or k is equal to minus 5. This is the value of k. So that means the pair of straight lines for which we are given this equation becomes, now the equation becomes 5x squared plus 40 upon 3xy minus 5y squared is equal to 0. So now, what is the formula for, you have to find out angle between the pair of lines. What is the formula for angle between the pair of lines? For between pair of lines, it's given by tangent of theta is mod of 2 root h square minus ab upon a plus b, right? So now, yeah, this is under the whole root. Wait. So now, a is the coefficient of x square and b is the coefficient of y square. A plus b is equal to 0. That means tangent of theta will be infinity. And tangent of theta is equal to infinity at 90 degree. That means they are perpendicular to each other. Okay. Let's check with the options. They are perpendicular. That means D option is the correct answer. Hope you understood this. Let's move to the next question then. Here is a correction for the formula. I was confused. This root lies not in the denominator. This is only for the numerator. Okay. So I hope you got the formula, because remembering such formulas will make your calculations a lot easier. Also remember one thing: when the coefficient of x square and the coefficient of y square, the sum of them is equal to 0, then the lines are definitely perpendicular to each other. This is a special case. Let's move to the next question, number 48. It says, if a line L is common to the pair of lines 6x square minus xy minus 12 square is equal to 0 and this, then the combined equation of the two lines will be. So first line is 6x square minus xy minus 12y square is equal to 0. Let's do splitting the middle term. So you will have 6x square. Okay, fine. This will be the two. I want the two such numbers. The product should be 72, and the sum should be -1. So those two are probably 9 and 8. -9xy plus 8xy minus 12y square is equal to 0. This gives you the two factors as 3x plus 4y and 2x minus 3y is equal to 0. And now the second line, 15x square plus 14xy minus 8y square is equal to 0. So now I have two such numbers whose product is equal to 120 minus 120 and the sum is equal to 14. So those two numbers will be this will be 8. Let me check with two such numbers. So it's plus 20y minus 6y minus 8y square is equal to 0. So the two factors will come out to be 3x plus 4y and 5x minus 2y is equal to 0. So if I look at both of them, 3x minus 4y is the common line. 3x plus 4y is common line. Therefore, combined equation of other two lines will be 2x minus 3y, 5x minus 2y is equal to 0. So on solving this, you will get 10x square minus 19xy plus 6y square is equal to 0. So that is our answer. When you will open up, you will get this 10x square minus 19xy plus 6y square is equal to 0. And this is our option A. Hope you got that. Next is question number 49. If L is the line passing through the point 1, -1, 1 and parallel to the common line of the pairs of line this and this, then equation of the pair of line joining the origin to the point of intersection of this curve and the line L is. So first thing, you have to find out common line of two pairs. So first is 6x square minus xy minus 12y square is equal to 0. Second line is 15x square plus 14xy minus 8y square is equal to 0. This is the same equation which we solved in the previous question, right? Same two equations, pair of line equations. So here the two lines came out to be 3x plus 4y, 2x minus 3y is equal to 0, and 3x plus 4y, 5x minus 2y is equal to 0. So the common one was 3x plus 4y. Common line is this. Now equation, next is it's saying equation of the pair, sorry, equation of L is given by, see the point is minus 1 comma 1, so equation will be y minus 1 upon minus 3 upon 4, because it is saying it is parallel to this common line. So what is the slope from here? Slope will be given by minus 3 by 4. I hope you get like how do you get the slope? Slope is actually equal to y upon x. So you will solve it. You will get the value of y upon x is equal to minus 3 by 4. Correct? So this is the slope, and x minus of minus 1 will be plus 1. This gives you y minus 1, 4y minus 4 is equal to minus 3x minus 3. This gives you 3x plus 4y minus 1 is equal to 0. This is the equation of the line L. Now, next, homogenizing given curve with this line 3x plus 4y minus 1 is equal to 0. What we get? See, it was 2x square upon minus 2x square minus xy minus y square. Let's write it first. The equation was 2x square minus xy minus y square plus x minus y is equal to 0. And line L, so this is 3x plus 4y minus 1 is equal to 0. So homogenizing both of these lines, you will get 2x square minus xy minus y square plus 3x plus 4y into x minus y, 3x plus 4y is equal to 0. Okay, so this will give me, like, open it up, 2x square minus xy minus y square plus 3x square plus 4xy minus 3xy minus 4y square is equal to 0. This will give me 5x square minus 5y square. So minus this one and this will get cancelled. So that's it. This is equal to 0, which gives you x square minus y square is equal to 0. So this is the answer, option C. Hope you got that. Let's move to the next question, number 50. It says from a point 0, a 0, comma 3 on the circle, which is given by this equation, and a chord AB is drawn and is extended to a point Q such that AQ is equal to twice of AB. Then the locus of Q is equal to. Now in this question, let's draw the circle. This is the circle. Let the center be C. Now what are the coordinates for the center? It's minus 2 plus 3. Right? So C is minus 2 and 3. Now it says a point 0, comma 3. There is a point 0, comma 3 over here. Let it be A 0, comma 3 on this circle, and a chord AB is drawn. So there is a chord AB. Here is B. This chord AB is drawn and it is extended to a point Q. This is extended to a point Q. Let the coordinates of Q be H, comma K, such that AQ is equal to twice of AB. If this is equal to this, So that means B is the midpoint on AQ. Correct? So what are the coordinates of B? B will be equivalent to, applying the midsection formula, you have 0 plus h upon 2, 3 plus k upon 2. That gives you coordinates of B as h by 2 and k plus 3 upon 2. Right? Now it says B is lying, it is said chord AB, that means B lies on the circle. So if B lies on the circle, then it will definitely satisfy this particular equation. Let's fill in the coordinates. It will be h by 2 plus 2 whole square plus k plus 3 upon 2 minus 3 whole square is equal to 4, which gives you h plus 4 whole square upon 4 plus k minus 3 square upon 4 is equal to 4. That means this is equal to, which gives you h plus 4 whole square, k minus 3 whole square is equal to 16. So this is the required locus. You have to find out the locus of Q. Then we have, I think, option A as the correct answer. Hope you understood. Let's move to the next question, number 51. It says, if M1 and M2 are slopes of the tangents drawn from this point to this circle, then 9 M1 square plus M2 square is equal to. So let's see, this is the circle. Now, there is an external point P with the coordinates this 1, comma, minus 3. I'll draw two tangents, A and B. So if M1 and M2 are the slope of the tangents from this point, so this is having the slope M1 and this is having the slope of M2 from this point to this circle, then 9M1 square. Okay, let's write down the equation first. X squared plus y squared minus 6x plus 4y plus 12 is equal to 0. So let's write it in the form. It will be x minus 3 whole square plus y plus 2 whole square is equal to 1. That's by completing the squares. I hope you can do that. Okay, let's discuss it once again, how we can do this. So original equation was x squared plus y squared minus 6x plus 4y plus 12 is equal to 0. X square minus 6x plus 9 and plus y square plus 4y plus 4. This and I have subtracted a 1 also from here because I have, this will be 13 then. So this will be x minus 3 whole square plus y plus 2 whole square is equal to 1. Right? Now, equation of the tangents. It is y plus 2 is equal to m into x minus 3 plus minus 1 upon 1 plus m square. Because it passes through, because this tangent passes through 1 comma minus 3. So you will have minus 3 plus 2 is equal to m into 1 minus 3 plus minus root of 1 plus m square. This is minus 1 upon, this is minus 2m plus minus root of this. Okay, so 2m minus 1 is equal to plus minus this, squaring both sides, you will have 4m square plus 1 minus 4m is equal to 1 plus m square. So you will have 3m square minus 4m is equal to 0, or this, that means either m is equal to 0 or 4 by 3. This is equivalent to m1. Now, similarly, I'll calculate m2 also. If I'm taking m1 as 0, m2 will be 4 by 3 or either case. Now, you have to find out 9 m1 square plus m2 square. So, this is equal to 90 square plus 16 by 9. This is equal to 16 in any case, right? That means option A is the correct answer. Hope you got that. Let's move to the next question, number 52. It says if A and B are the point of contact of the tangent drawn from this point, let's make this figure also. This is a circle and A, B, there is an external point. Let's draw two tangents, this and this. So, this is the point P. A and B are the point of contact of the tangents drawn from this to this circle, that is x square plus y square minus 8x minus 10y plus 5 is equal to 0. Here, g is minus half the coefficient of x, that is equal to 8. So, that is equal to so it is minus 4 and f is similarly minus 10 by 2 minus 5. C in this case is 5. So you know the formula for the radius. It is given by root of g square plus f square minus c, that is equal to 16 plus 25 plus 25, that is equal to 50. Sorry, 25. Sorry. This is equal to 16 plus 25 plus 5, that is equal to 36. Question number 52, it says if A and B are the point of contact of the tangents which is drawn from this point to this circle, chord AB subtends an angle theta at P, then tan theta is equal to. Let's make the figure. If this is the circle, let this be the external point P with the coordinates minus 2, comma minus 3. So this is the tangent here at A and this is another tangent at B. Right? And theta is the angle between these two tangents. Next, it's given chord AB subtends an angle theta. Okay, chord AB subtends an angle theta at P. Again, tangent of theta is equal to. Okay, so this is the center of the circle. So let's write on the circle equation x square plus y square minus 8x minus 10y plus 5 is equal to 0. You know, g is half the coefficient of x, that is equal to minus 8 by 2 minus 4. F is half the coefficient of y, that is minus 5. C is the constant, which is 5 in this case. You know, the radius is given by, from the equation of the circle, the radius is given by g square plus f square minus c, which is equal to 16 plus 25 minus this, that is equal to plus minus 6. Of course, you can't have 6 as negative, so radius is plus 6. Now, length of the tangent is given by root of S1. If S1, I'm taking the length of the tangent. The formula, please note down. This is given by x1 square plus y1 square, 2gx1 plus 2fy1 plus c. So here x1, y1 is minus 2, comma, minus 3. So this will be root of S1 minus 2 square is 4, minus 3 square is 9, plus 2 into minus 4 into minus 2 plus 16 plus 2 into f was minus 5. 2 into minus 5 into minus 3. This is equal to 30 plus 5. this is going to give you 8. Okay. All right. So now theta can be given by, that is the angle between this theta which we're looking for between the two tangents, which is subtended by the chord AB, is theta is equal to 2 inverse R upon root S1. So this is equal to 2 tan inverse. R came out to be 6 and this is equal to 8. That is 3 by 4. So 2 theta by 2 is equal to tan inverse 3 by 4. You know, tangent of theta is given by 2 into tan theta by 2 upon 1 minus tan square theta by 2. So from here you have tangent of theta by 2 is equal to 3 by 4. So this is equal to 2 into 3 by 4 upon 1 minus 9 upon 16. That will give you 6 upon 4 or 3 by 2 upon 7 by 16. That will be equal to 3 by 2 into this. So 24 upon 7. This is the answer to the question, tangent of theta. That means I have option B as the correct answer. Hope you understood. Let's move to the next question. Question number 53. Equation of the transverse common tangent to these circles is this, and this pair of circles is, first of all, the first one, circle x square plus y square minus 6x plus 8y plus 9 is equal to 0. The second one, x square plus y square plus 2x minus 2y plus 1 is equal to 0. In this, the center, you know, the formula for the center, not actually formula, but center is given by minus g minus f. G is half the coefficient of x and f is half the coefficient of y. This is the center. So minus half the coefficient of x, 3, minus half the coefficient of y, minus 4. Here, center, let it be C2 and this one be C1. So this is equal to minus 1, comma 1. Minus half the coefficient of x, minus half the coefficient of y. Now radius, you know, in the last question also we did, it's g square plus h square minus c. So here R1 is equal to 9 plus 16 minus 9, that will be 4. And R2 is root of 1 plus 1 minus 1, that is equal to 1. So R1 is equal to 4 and R2 is equal to 2. Now we got the centers also. C1, let's write it here. C1 was equal to 3, 4, which was the coordinates for center 1, and center 2 was equal to minus 1, comma 1. Let's calculate C1, C2 using the distance formula. So this is equal to 3 minus of minus 1, that is equal to plus 4, 4 square, 4 minus 1, that is equal to 3 square. This is going to give you 5. And R1 plus R2 is 4 plus 1, that is 5. So you see one thing, C1, C2 is equal to R1 plus R2. That means if I'm having the two circles like this, actually they're not touching, intersecting, they're just touching. Okay, they are touching only. So this is a C1 and R1, and the second one is C2, R2. So if these two are equal, that means circles touch each other externally. Therefore, transverse common tangent is given by x square plus y square minus 6x minus y plus 9 minus x square plus y square plus 2x minus 2y plus 1 is equal to 0. This will give me like x square and y square, they will cancel out. And this will be minus 8x minus 6y plus 8 is equal to 0, or 4x plus 3y minus 4 is equal to 0. This is the answer. Let's check. We have option A as the correct answer. Hope you understood. Next is question number 54. It says if theta is the angle between these two circles, this and this, then 7 secant theta minus 18 cos theta is equal to. So the first circle is x square plus y square minus 2x minus 4y minus 4 is equal to 0. And the second one is x squared plus y squared minus 8x minus 12y plus 43 is equal to 0. You know the center is given by minus half the coefficient of x, that is 1, minus half the coefficient of y, which is 2. Here, the center, this is C1, C2 center, this is given by similar thing, 4, 6. And radius r, this is given by root of g square plus f square minus c. So this is equal to 1 plus 4 minus of minus c. This is going to be giving me 3. And R2, root of 16 plus 36 minus 43, that is equal to 52 minus 43, that is equal to 3. Correct? So we got all the both the roots as 3 and 3. Let's go for this now. Okay. Center 1, 1, 2, R1, 3, center 2, 4, 6, and R2 is equal to 3. Now D, so these are the two circles. Let's see. The two circles are something like this. This is C1 and C2. So let's calculate D. D is equal to C1, C2, that is equal to root of 3 square, 1 minus 4, that is equal to minus 3, or minus 3 square is equal to 3 square, plus similarly 6 minus 4, that is equal to 4 square. This is going to give me 5. So the diameter, that is C1, distance between the two is 5. We got this thing. Now, you know, cos theta is given by R1 square plus R2 square minus D square upon 2 R1 R2. That is equal to R1 was 3, so 9 plus R2 was also 3, so 3 square 9 minus D is 5, so 5 square is 25 upon 2 into 3 into 3. This gives me 18 minus 25, which is minus 7 upon 18. This is cos of theta. And you have to find out this 7 secant theta minus 18 cos theta. 7 secant theta minus 18 cos theta. Mod is given by 7 into secant theta is actually inverse of it. So this will be 18 upon 7 minus 7 minus 18 into minus 7 upon 18. This is going to give me minus 18, and sorry, here was not comma, here was minus. Okay, minus this will cancel and this will cancel. So this will be plus 7. That's going to give me 11. Okay, so 11 is the correct answer. Option A is the correct answer. Hope you got that. Let's move to the next question then. Question number 55. It says if 0, 3 by 4 is the radical center for circle S, S dash, and S double dash. These are the three equations for three circles. Then the distance between the radical center and the center of the circle S dash is equal to 0 is. All right, let's write down the three equations. S dash, S is given by x square plus y square plus alpha x plus 6y is equal to 0. S dash is x square plus y square plus 2 alpha x plus alpha y plus 6 is equal to 0. And S double dash is equal to x square plus y square plus 6 alpha x minus alpha y plus 3 is equal to 0. Now, the three equation for the three radical axes are s minus s dash, the first one. This is given by, see, these two are subtracted. So this is alpha x plus 6 minus alpha y minus 6 is equal to 0. S minus s double dash is minus 5 alpha x plus 6 plus alpha y minus 3 is equal to 0. S dash s double dash is equal to minus 4 alpha x plus 2 alpha y plus 3 is equal to 0. These are the three radical axes. Now you know the radical center is the point of congruence of the three radical axes. So their point of congruence is radical center, right? So 0, 3 by 4, this is the radical center, and that will, therefore, this will satisfy s minus s dash is equal to 0, right? Actually, this will satisfy all these three equations, but we are concerned about s dash is equal to 0. So this will also satisfy s minus s dash is equal to 0. And what was that equation? It was minus alpha x. So minus alpha into 0 plus 6 minus alpha into 3 by 4. Minus 6 is equal to 0. That gives you 6 minus alpha is equal to 6 multiply 4 upon 3, that is 2. So 6 minus alpha is equal to 8, or alpha is equal to minus 2. Now in the question, you have to find out distance between the radical center. We already know the radical center, and center of the circle. S dash is equal to 0. So S dash, we have the whole thing, but we don't know the value of alpha in S dash. We got the value of alpha. Now let's put that value in S dash. So this equation of the circle S dash will be x square plus y square minus 4x minus 2y minus 4x minus 2y plus 6 is equal to 0. So from this circle, you know, center is given by minus half the coefficient of x, that is 2, minus half the coefficient of y, which is 1. And you already know the radical center is 0, 3, 5, 4. And you have to find the distance between the two. So required distance is given by root of 2 minus 0. So that's 2 square. 1 minus 3 by 4. That is equal to 1 by 4 square. That gives you 4 plus 1 upon 16, which is equal to 65 upon 16 root, which is root of 65 upon 4. So this is the correct answer to the question, root of 65 upon 4, which is option C. So this is the correct answer. Hope you understood. Next, question number 56. It says the vertex and focus of the parabola 2x squared plus 5y minus 6x plus 1 is equal to 0 are. So this is the given equation. Now let's convert this whole into the perfect squares form. So I'll say 2x square minus 6x plus 9 by 2 plus 5y minus 1 minus 9 by 2 is equal to 0. Now let's take 2 common from here. You will have x square minus 3x plus 9 by 4. This is equal to minus 5y, and here was plus 1, right? Okay, so this is going to be minus, and minus on this side. When I'll take it on this side, this will be converted into plus 7 by 2. Now this is 2 into x minus 3 by 2 whole square is equal to minus 5. I'll take this common. So you will have minus 7 by 10. Okay. Now, let's say this is equal to 2x squared is equal to minus 5y, or x square is equal to minus 5 by 2y, capital Y, capital X, right? Where x is equal to x minus 3 by 2 and y is equal to y minus 7 by 10. Hope you got that. Okay. Now, yeah, what do you have to find out? Vertex and the focus. All right. So for vertex, let's put this capital X is equal to 0 and capital Y is equal to 0. So you will have x minus 3 by 2 is equal to 0 and y minus 7 by 10 is equal to 0, which will give you x is equal to 3 by 2 and y is this. So your vertex becomes this. Now for focus. X is 0 and y is equal to minus a. So x minus 3 by 2 is equal to 0 and y minus 7 by 2 is equal to a. A was equal to minus 5 by 8. You have x square is equal to 4a y form. So 4a is equal to minus 5 by 2. How? Look over here. So this was the equation. A was equal to minus 5 by 2, which gives you a is equal to minus 5 by 8. So from here, y minus 7 is equal to minus 5 by 8, or small y on solving minus 5 by 8 plus 7 by 10. This is equal to 3 by 40. On solving, this will give you 3 by 40. So you got the value of small x and small y. Therefore, the focus is equivalent to 3 by 2 and 3 by 40. So from here, you have x is equal to 3 by 2. Right? So you got both the things, focus and the vertex. This is your focus. Number 2, this is what we needed. And this is vertex. And this is we needed at the first place. So we have option D as the correct answer. Hope you got that. Next, question number 57. It says the axis of the parabola is along the line y is equal to x, and the distance of its vertex A from this point is root 2, and that of its focus S from the origin is 2 root 2. If A and S lie on the first quadrant, then the equation of the parabola in the parametric form is. In this question, it says as the axis of the parabola, axis of the parabola is along the line y is equal to x. Therefore, what are the coordinates of focus and vertex will be h comma h and k comma k. So these are the coordinates of focus and the vertex respectively. Now, distance of vertex from origin is root 2. Distance of vertex from origin is root 2. So vertex was h comma h. Sorry, vertex is k comma k. Therefore, k square plus k square is equal to root 2 square, or 2k square is equal to 2, which gives you k is equal to 1. Now the distance of focus from origin. Second thing. Now, distance of focus from origin is given by h square plus h square. is equal to 2 root 2 square, which gives you 2h square is equal to 8, or h is equal to 2. Okay, we got the value of h and k. Therefore, the vertex is equivalent to 1, 1, and focus is equivalent to 2, 2. Right? Now, directrix passes through, it's given that directrix passes through where it is the axis of the parabola, this distance is this, and the S, A and S lies in the first quadrant. Question number 57, it says the axis of the parabola is along the line y is equal to x, and the distance of its vertex A from origin is root 2, and that of its focus S from origin is 2 root 2. If A and S, they lie in the first quadrant, then equation of the parabola in the parametric form is. Now, as the axis of the parabola is along the line y is equal to x, then let's say the focus has the coordinates HH, and let's say vertex has the coordinates as KK. Now, it's given that the focus is having the distance from the origin is 2 root 2. So that means h square plus h square is equal to 2 root 2 whole square using the distance formula. Similarly, k square plus k square is equal to root 2 square. That gives you 2h square is equal to 8, or h will come out to be plus minus 2. Similarly, 2k square will be equal to 2, or k will come out to be plus minus 1. Now, it is said that A and S, vertex and focus, they lie in the first origin, first quadrant. Therefore, H will have the coordinates as 2, 2, and K will have the coordinates as 1, 1. Correct? 2, minus 2 is not possible. Minus 1 are not possible, because then focus and the vertex will lie in the third quadrant. Correct? Now, it is said directrix. Now, from here, directrix passes through origin and is perpendicular to the line y is equal to x. What is the slope of this line? 1. So that means what is the slope of directrix? Since they both are perpendicular, so directrix will have the slope as -1, which will give you y minus 0 is equal to -1, x minus 0. That will give you x plus y is equal to 0. Now, the parabola will be given by x minus 2 square plus y minus 2 square is equal to x plus y whole square upon 2. This on solving, let's solve it. X square plus 4 minus 4x y square plus 4 minus 4y whole multiplied by 2 is equal to this. On solving, you will have x square plus y square minus 2xy minus 8x minus 8y plus 16 is equal to 0, or you will have x minus y whole square plus 16 is equal to 8 into x plus y. Correct? So let's start with the options now and see which one satisfies the given parabola equation. Let's pick up the first one. X is equal to t plus 1 whole square. Now let's use A, where you have x is equal to t plus 1 whole square and y is equal to t minus 1 whole square. So this equation will become t plus 1 square minus t minus 1 square plus 16 is equal to 8 into t plus 1 square plus this. So you will have here, this is something a plus b into a minus b. This will be t plus 1 plus t minus 1, t plus 1 minus t plus 1 plus 816 is equal to 8 into this will be t square plus 1 plus 2t. This. So here you will have 2t into 2. Here was square, I was missing this. Yeah. So this is whole square plus 16 is equal to 8 into 2t square plus 2. This will give you 4 raised to power 2. This is going to give me 16t square plus 16. This is equal to 16t square plus 16. That means we have first time, like first option came out to be the correct one. That's very good because we don't have to waste our time on solving other options. We are already short of time. This question was a bit lengthy one. So we have option A as the correct answer. Okay, hope you got that. Next, question number 58. It says, let S be given by this equation, ellipse equation, and S dash will be given by this equation, be two intersecting ellipses. If P, Q are their points of intersection, then what is the value of this given expression? All right. So first is you are given the two ellipses as S is x square upon a square, y square upon b square is equal to 1. Yeah. And the second one, S dash is equal to x square upon alpha square, y square upon beta square minus 1, or this is equal to 1. Like, fine. Now, P, which is given by a cos theta, b sin theta, and Q, which is given by a cos pi by 2 plus theta, b sin pi by 2 plus theta. So, you know, cos pi by 2 plus theta, it's actually equal to sin theta. So, this is minus sin theta. So, minus a sin theta, this is minus, sorry, b cos theta. These are the coordinates of P and Q. Now, they are the intersecting points. That means they will satisfy both the lines. I'll pick up only S dash right now because I'm concerned with alpha square and beta square. So, somewhere I'll go with the second one first. So, if P is the point which is lying on S dash, that means S dash will satisfy this one. See, S dash was equal to x square upon alpha square plus y square upon beta square is equal to 1. So, x can be put as, if I'm saying for point P, I'm satisfying the point P. This is given by a cos theta whole square upon alpha square plus b sin theta whole square upon beta square is equal to 1. And if Q is set, let's solve it further. If Q is satisfying, then this will be given by minus a sin theta whole square upon alpha square plus b cos theta whole square upon beta square is equal to 1. Now, adding both the equations. Let's add both of them. So, you will have adding both the equations. You will have a square will be common upon a square upon alpha square will be common. And you will have cos square theta plus sin square theta plus b square upon beta square sin square theta plus cos square theta. This is equal to 2. You know, this is equal to 1. So, a square upon alpha square plus b square upon beta square is equal to 2. Let's take the LCM. You will have a square beta square plus b square alpha square is equal to 2 alpha square beta square. Correct? I hope. What do you had to find out in the question? Half of alpha square beta square plus, okay, this. Half of a square beta square plus b square alpha square. I think we have this. A square beta square, b square alpha square. Half, I will take this 2 on the left hand side. So, half of a square beta square plus b square alpha square is equal to alpha square beta square. So, this is the value to the, this is answer to the question. This comes out to be alpha square beta square. That means we have option D as the answer. Hope you got that. Let's move to the next question. Question number 59. If P theta 1 and Q theta 2 are 2 points on this ellipse with the eccentricity E, and PSQ is the focal chord, and tan theta 1 into tan theta 2 is equal to this, then E and S are. Okay, in this question, S may have two values. It may be either AE comma 0 or minus AE comma 0. Right? So in this case, tangent of theta by 2 multiply tangent theta 2 by 2 is equal to E minus 1 upon E plus 1. And in this case, tangent theta 1 by 2 multiply tangent theta 2 by 2 is equal to inverse, that is this E plus 1 upon E minus 1. In this case, this is of course less than 1, and E plus 1 upon E minus 1 is of course greater than 1. Now, according to the question, we are given this value. According to the question, tangent of theta 1 by 2, tangent of theta 2 by 2 is equal to minus 2 root 2 plus 3. Let's take the mod on both the sides. You will have tangent theta 1 by 2, tangent theta 2 by 2 is equal to this, right? And of course, this is greater than 0. So which value I will take? I will take E plus 1 upon E minus 1 is equal to minus 2 root 2 plus 3. So let's solve. You will have E plus 1 is equal to minus 2 root 2 plus 3 into E minus 1. This will give you E plus 1 is equal to minus 2 root 2E minus 2 root 2 plus 3E minus 3. E plus 1 plus 2 root 2E minus 2 root 2 plus 3E minus 3 is equal to 0. Now let's collect E terms. So I'll take, this will be 4E plus 2 root 2E is equal to 2 plus this. So let's take 2 root 2 E common from here. I'll be left with root 2 over here plus 1. And this one will be, I'll take 2 common. So 1 plus root 2. Correct? These are going to get cancelled. And even the 2 and 2 will also cancel. You will have the E value to be 1 by root 2. Right? And in this case, of course, the S was equal to minus A E 0. That means A was, okay, E is this and multiply minus A comma 0. So the coordinates will be minus A upon root 2 comma 0. Let's check with the options. We have to find out the E and S. E is 1 by root 2, which is in C and D option. And S is minus A upon root 2. That means option D is the correct answer. Hope you got this. Next is question number 60. Let S be the focus of this hyperbola lying on the positive x-axis, and P this, given by this, be the point on the hyperbola. You have to find out SP. Very simple. Actually, the formula for SP will be given by AX1 plus A. We know the value of x1, that is 5, and we have to find out E and A. What is A? You can get from here. From here, A is equal to root of 16, that is equal to 4, and B square is equal to 9, which gives you B is equal to 3. Correct? I got A as 4 and B as 3. Let's find out E. E is given by 1 plus B square upon A square, which is equal to 1 plus 9 upon 16 whole under the root. So 25 upon 16 root. This will give me plus minus 5 by 4 as the value of E. Right? I got A as 4, B as 3, E is plus minus 5 by 4. So let's find out SP. It is EX1 plus minus A. I hope I wrote plus minus. Okay. So E is just like 5 by 4 multiply x1 is 5, right? Okay, plus minus A is 4. So this comes out to be 20 upon 4 plus 4, or 20 plus 4 minus 4. This is equal to 20 plus 16. I hope I'm doing, sorry, this is 25, right? So this has got to be 41 by 4 and 9 by 4. These are the two possible values, 41 by 4 and 9 by 4. 41 by 4 is not in the options, but 9 by 4 is option C, and that stands to be the correct answer. Hope you got that. Let's move to the next question, number 61. P theta is given by this. These are the coordinates. Where theta lies between 0 and pi by 2. That means theta is in the first quadrant. Is a point on this hyperbola where theta is the parameter in its parametric form. Then 2x1 plus 9, 2x1 plus 9 sine square theta is equal to. Given equation of the hyperbola is 25 upon x squared minus y squared upon 9 is equal to 1. Here, P theta is given to you as V theta 1. This is equal to C. What is the value of A? This is root of 25, that is 5, and the value of B is equal to 3. Correct? 5 secant theta and 3 tangent of theta. You know, the coordinates of any point in its parametric form are given by A secant theta and B tangent of theta. Correct? Okay, sorry. So here, all right. So these are the coordinates for the point P. Now that means over here, this is x1, 5 secant theta. X1 is 5 secant theta, and 3 root 5 upon 2 is 3 tangent of theta, right? These are the coordinates. So you have tangent of theta is equal to root 5 by 2. And x1 I will not touch. I don't need it right now because I have the definite value from here. I'll use this one. Correct. What in the question we need? I would need 2x1. X1 I already got. And now I want sine square theta. But I have tan square theta. So let's get to there. Let's get to reach sine square theta. You know tangent theta? You know this thing, 1 plus tangent square theta is equal to secant square theta. That gives you secant theta is equal to root of 1 plus tangent square theta, which gives you secant theta is root of 1 plus, and tangent square theta was root 5 by 2. This gives me 5 by 4. That is equal to 9 by 4, or secant theta comes out to be plus minus 3 by 2, right? Next, I got the value of secant theta. I have to go to sine theta now. So, you know, sine square theta plus cos square theta is equal to 1. So, sine square theta, I got this as secant theta. So, what is cos theta? It's 2 by 3. So, sine square theta plus 4 by 9 is equal to 1, which gives me sine theta is equal to root of 1 minus 4 by 9. That is equal to 5 by 9 root. Or this, okay, 3. This is the value of sine theta. Now I have everything to solve the question. We needed to find 2x1 plus 9 sine square theta. X1 was equal to 5 secant theta plus 9 sine square theta was 5 by 9. So you have, okay, 5 secant theta we also calculated, it is 3 by 2. So 2 into 3 by 2, that's 15 by 2 plus 5. This will be equal to 12, 25. Okay. 15 plus 10 upon 2. So that is equal to give me a Sorry, there's a slight mistake. It was 2x1. So this 2 is got to be multiplied with 5 secant theta only, not with this 5. Okay. Hope you got this. So this will be 15 plus 5, that is equal to 20. All right. We have 20 as the answer to the question. That is option C. Hope you understood this. Right. Next is question number 62. If the points A, B, C, which are given by these coordinates, form a right angle triangle, then the number of possible values of K is. Okay, so you are given 3 vertices. Let's write them. A is 135, 2, 4, 6, and C is 4, 5, and K. Now, they are forming a right angle triangle. I don't know at which it is forming, but let's calculate AB, BC, and AC. AB will be given by, AB will be given by 2 minus 1. These are the position vectors, right? So, AB will be given by 1, 1, and 1, right? 2 minus 1, 3 minus 4, 5 minus 6, correct? Similarly, BC will be given by 4 minus 2, that's 2, 5 minus 4 is equal to 1, K minus 6. And next, AC will be given by 4 minus 1, that is 3, 5 minus 3, that's 2, and K minus 5. These are the 3 points. Now, because they are forming the right angle triangle, as these are forming right angled triangle, therefore the dot product of both AB and BC is equal to 0, right? So let's form the dot product AB into BC. These are the ones. So this gives me 2 plus 1 plus K minus 6 is got to be 0, which gives you K is equal to 3. Or AB into AC is equal to 0, which will give you 3 plus 2 plus K minus 5 is equal to 0. This will give you K is equal to 0. Or BC into AC is equal to 0. That gives you 6 plus 2 plus K minus 6 into K minus 5 is equal to 0. This will give me K square minus 11 K plus 30 plus 8 is equal to 0. Or K square plus 11K plus 38 is equal to 0. Right? Over here, you will find out that the discriminant, which is given by B square minus 4AC, which is B square is 121 minus 4 into 30, this 38 into 1. So this is 128 minus this. This is less than 0. This is a negative value. So therefore, this one does not have any real value for K. No real value for K is possible here. So that means the number of possible value of K is only 2, this and this. So these are the only 2 possible values, correct? Let's see, we have option A as the correct answer. Hope you got that. Let's move to the next question. Question number 63. Let A be given by this point 3, 4, 0, and B is this, and C is this, and D is this. Is the acute angle between the lines AB and CD, then cos theta is equal to. So, okay. Theta is the acute angle between AB and CD. Let's write down AB and CD vectors first. So, AB vector is given by 4 minus 3, I plus 4 minus 4j plus 4 minus 0k. That gives me I plus 4k as the position vector for AB. Similarly, CD vector can be given as 1 minus plus 6 I 1 minus 2j 2 minus 3k, which will be 7I minus j plus minus k vector. So these are the two A and B vector. Now theta is a acute angle between them. Therefore, we can write, first of all, let's find out the mod of them also. This is equal to root of 1 square plus 4 square, which is 17 root. Similarly, CD is given by 7 square plus minus 1 square plus minus 1 square, which is gonna give you 51 root. Now, you know, cos theta is equal to AB dot product of CD divided by their modulus. This is equal to AB into CD is 7 minus 0 minus 4 upon. This is equal to root of 17, root of 51. That's going to give you 3 upon root of 17 into root of 17, 3s. So this is going to give me root 3 upon 17. Okay, this is the answer to the question, root 3 upon. This is not there, but yes, we have option B, which is similar, which is equivalent to this answer. So that means we have option B as the answer. Hope you got that. Next question number 64. A plane containing two lines whose direction ratios are this and this passes through this point. If the plane also passes through 3, minus 1, comma 4, then K is equal to. All right. First of all, you are given, let's say the vector perpendicular to the plane will be given by I, J, K. Now it passes through minus 1, 2, 1, 1, 3, 2, which can be written as this is going to give me 4 minus 3 minus j minus 2 minus 1 plus k multiply minus 2 minus 1, which is I minus 3j minus minus plus. And here is minus, give me a minute, k cap. So this is 3, sorry, minus 3 and minus 2, which is going to give me minus 5k. Okay, so this is a position vector for the perpendicular, which is perpendicular to the plane. Now the direction ratios of this normal are, direction ratios of normal are 1, 3 and minus 5. Therefore, the equation of the plane will be given by, see, since it passes through 2, 1, comma k, so the equation can be given by x minus 2 into 1 plus y minus 1 into 3 z minus k minus 5 is equal to 0. Now it's given that this also passes through the point 3 minus 1 comma 4. It also passes through 3 minus 1 and 4, which will give you 3 minus 2 into 1 plus minus 1 minus 1 into 3 plus z is 4 minus k minus 5 is equal to 0. That's gonna give me 1 minus 6 minus 20 plus 5k is equal to 0, or 5k is equal to 25, which gives me k is 5. So the value of k is equal to 5. This is what you needed to find in the question. Option A is the correct answer. Hope you understood this. Then let's move to the next question. Question number 65. Let A be the matrix which is represented by AIG, be an n by n matrix defined by this for all I belonging to J and 0 otherwise. Therefore, this is a diagonal matrix. Now, if M is the trace of A and limit K approaches 1, N minus M upon 1 minus K is 171, then you have to find out the value of N. All right. So first thing, what is a trace of a matrix means? Trace of, this is a square matrix, right? N by N. So trace of a square matrix is the sum of its diagonal entries. All right. So over here, according to the question, M is trace of A. That means M is equal to A11 plus A22 plus A33, like whatever, till AN. Now, M is equal to, see, this is equal to K raised to power I. So that means it's K plus K square plus K, so on till K raised to power N. Now, your third thing that's given, that limit K approaches 1, N minus M upon 1 minus K is equal to 171. So, limit K approaches 0, N minus M upon 1 minus K is equal to 171. You can also write it as limit K approaches 1, M minus N upon K minus 1 is equal to 171. This can further be written as limit K approaches 0, K, M can be written as K plus K squared till K raised to power N minus N can be written as 1 plus 1, so on till N times. This whole divided by K minus 1 is equal to 171. This further can be written as limit K approaching 1, K minus 1 upon K plus minus 1 plus K square minus 1 upon K minus 1, so on K raised to power N minus 1 upon K minus 1. This is equal to 171. Now, you know one thing, limit using limit x approaching 0, x raised to power n minus a raised to power n upon x minus a is equal to n into a raised to power n minus 1. Using this formula, you can write it as limit k approaching 1. So this will be, sorry, not limit, I have opened the limits now. So this will be 1 plus 2 plus 3 plus so on till n is equal to 171. You know the formula for the sum of first n natural numbers? It's given by n into n plus 1 upon 2. This is also the same. So n into n plus 1 upon 2 is equal to 171. Let's open it, n square plus n minus, okay, 171 into 2. This is equal to 0. So n square plus n minus 342 is equal to 0. So you have to find out the two factors and let's solve that. Two factors. The two factors will be minus 19 and plus 19 and minus 18 and minus 342 is equal to 0. This will give you n plus 19 and n minus 18 as two factors. So n is not going to be negative. So n is 18. This is the correct answer to the question. We have option A as the answer. Hope you got that. Let's move to the next question, number 66. Limit x approaching infinity, x cube, this whole thing is equal to. Okay, now these type of sums, they are not so tough, but they have to be solved very patiently because very high chances of making mistakes are there. So limit x approaching infinity, x cube, root of x square plus root of x raised to power 4 plus 1 whole root minus root 2x, limit x approaching infinity, x cube. Now let's multiply the numerator and the denominator by x square plus x raised to power 4 plus 1 minus root 2x, this multiplied by x raised to power 2 plus x raised to power 4 plus 1 plus this upon x square plus root of x raised to power 4 plus 1 plus root 2x. This is something a plus b into a minus b. So you will have limit x approaching infinity, x cube. Now a plus b into a minus b, this is a square plus b square. So this will give you x square plus root of x raised to power 4 plus 1 minus 2x square upon root of x square plus root of x raised to power 4 plus 1 plus this. Again, multiplying the numerator and the denominator with, this time it will be x square. Sorry, there is a chain, wait. So it will be subtracted. Next, it will be x approaching infinity, x raised to power 3, root of x square plus x raised to power 4 plus 1 minus x square upon root of x square plus this. So now, multiplying the numerator and the denominator with root of x raised to power 4 plus 1 plus x square upon root of x raised to power 4 plus 1 plus x square. This will give you a plus b into a minus b. Limit x approaching infinity, x raised to power 3 is this. X square plus this plus this, multiply this thing. So this will cancel and you will be left with 1 upon this whole term now. So limit x approaching infinity. Now let's divide the numerator and the denominator. Wait, this x cube, now I'm bringing this inside. Limit x approaching infinity. Let it be here. So this is 1 upon. Now I'll be taking x out. So there is x from here. I'll take x common from here. Then I'll take x common. You will be left with the 1 plus 1 upon x raised to power 4 plus root of 2 multiplied by 1 upon. I'll take x square common here. Okay, so now this will be 1 plus 1 upon x raised to power 4 plus 1. Now putting x as infinity, see these will cancel out first. So now let's put x is equal to infinity. So this will be 1 upon root of 1 plus root of 1 plus 0 plus root 2 multiply 1 upon root of 1 plus 0 plus 1. So this is actually not in the roots. So 1 upon, this will be root 2 plus root 2 multiplied by 1 plus 1. This is going to give me 1 this upon this. So you will have 1 upon 4 root 2. This is the answer to the question, 1 upon 4 root 2. That means we have option C as the answer. Hope you understood. Let's move to the next question, number 67. It says let fx is equal to this 3 minus x. If x is less than minus 3, it's 6. If x lies between minus 3 and 3, and it's 3 plus x when x is greater than 3. Where x, let alpha be the number of points of discontinuity of f and beta be the number of points where f is not differentiable. Then alpha plus beta is equal to. Okay, so here 3 things are given that at x minus 3, the left hand limit will be limit x h approaching 0 minus 3 minus h. So this is limit h approaching 0, 3 minus. See, over here h is negative, so this will be 3 minus x will be used. So this will be minus 3 minus h. Now this is given to you as 6. Right? Okay. So now this will be, yeah, okay. Now using the right hand limit. Right hand limit, h approaching 0, function of minus 3 plus h. Now this is equal to 3. You know, f of minus 3, if I'm putting f of minus 3 is going to give me 6. Now these both are equal. Therefore, the function is continuous at x is equal to minus 3. Right? Because both of these are equal. Now, let's try for x is equal to 3. The left-hand limit in this case will be, limit x approaching 0, f of 3 minus h, because this is positive. So, right? 3 minus h approaching infinity, the left-hand limit. This is equal to 6 now. Right-hand limit. Limit h approaching 0, 3 plus h. This is given by f of 3 plus h, that is 6. Okay. See, over here, this is the at x is equal to 3. The left-hand limit, I'll be using this 6 over here because at x is equal to 3, this interval will be used. Left-hand limit is going to be 6 and the right-hand limit is going to be 3 plus x. So 3 plus h, where this will be filled with 3 plus h. Okay. So this is again 6 when h is going to 0. And h is approaching infinity. This is also going to give me 0. Again, these both are equal. Therefore, function is continuous at x is equal to 3 also. Correct? So it was continuous at both of them. Therefore, the function is continuous. See, this was the breaking, right? Here was minus 3 and 3. These were two breaking points. Therefore, the function is continuous. For the rest of the points, the function was already continuous. Therefore, the function is continuous for or x belonging to real numbers. Correct? Therefore, alpha stands to be 0. What was alpha? Alpha was the number of points of discontinuity of the function. And beta is the number of points where function is not differentiable. So now the second case for finding beta. Now to find the continuity, differentiability, let's find out the first derivative of the function. This will be given by, so the function was 3 minus x, that means minus 1 for x less than 3. It was 6, so the derivative is 0 when x lies between minus 3 and 3. And then for x is greater than 3, it was equal to 3 plus x. That means it is equal to 1. Okay, the derivative is going to be 1. Now, the derivative of the function at x is equal to minus 3, the left-hand limit of it is, when it's approaching towards the left side, left-hand limit is minus 1 from this. And the right hand is going to give me 0 from here. These both are not equal, therefore, function is not differentiable at x is equal to minus 3. Now, for first derivative at x is equal to 3 minus, that is the left-hand limit. Now, this is equal to, again, this is going to give me, wait, it was 3 minus. Yeah, it's going to give me 0 from here. And f of the first derivative when it's approaching 3 plus, this is going to give me 1. Again, they both are not equal. Therefore, the function is not differentiable at x is equal to 3 also. So both the points, the function is not differentiable. Beta was the number of points where it is not differentiable. So we have beta as 2. You had to find out alpha plus beta. So the answer is 2. Right? So we have option C as the correct answer. Hope you understood. Let's move to the next question then. Question number 68. Before starting with the question, students, here's a quick reminder to visit our website www.examsnet.com. There you will find not only this, but a variety of similar type of entrance exam question papers for your practice. You can also download our app. You can get the link for the same in your description box. So let's start with the question number 68 now. It says a of fx plus b of 1 by x is equal to x plus 1. Let's write a of fx plus b of f1 by x is equal to x plus 1, and d by dx of x square fx is equal to 2x square plus 2x plus 1 by 3. Then what is the value of a minus b? So in this question, let's replace x by 1 by x. You will get a of a multiply f of 1 by x plus b f of x is equal to 1 by x plus 1. Now let's multiply this equation with a and this with b. You will get, this will be a square fx plus ab 1 by x is equal to ax plus a. And the second one, see, this is f of 1 by x. I will write down here. This will be a b f of 1 by x, and b square f x. This is equal to b by x plus b. Now let's do the subtraction of these two equations. You will get, these two will get cancelled, and you will have a square minus b square fx is equal to ax plus a minus b, and minus b upon x. Now let's multiply both the sides. Okay, fine. Now let's multiply both the sides by x square. You will have, and divide, taking this a square minus b square on the right hand side, you will have x square fx is equal to 1 by a square minus b square ax cube plus a minus b x square minus bx. Right? We are quite near to this one. We have got this thing. Now let's find the derivative of this function of the left hand side. So d by dx of x square fx is given by 1 by a square minus b square. This will remain as such, and this will be 3a x square plus 2a by minus b x minus b. Now, this is given to be equivalent to 2x square plus 2x plus 1 by 3. You can further write it as 3a upon a square minus b square x square plus 2 into a minus b, and the numerator, sorry, the denominator can be written as, this one can be written as a plus b into a minus b. So this is 2 upon a plus b x minus b upon a square minus b square. This is equivalent to 2x square plus 2x and plus 1 by 3. This is given to you in the question. That means 3a upon a square minus b square is equal to 2. 2 upon a plus b is equal to 2, and minus b upon a square minus b square is equal to 1 by 3. So this means 3a by 2 is equal to, 3a by 2 is actually equal to, see, I shouldn't have removed that a square minus b square. Okay, because that will be used in equating them. Correct? Now this is equal to a minus b, which is equal to minus 3b. And these all are equal to a square minus b square. I hope you got this step, right? Now, further, this can be written as that 3a is equal to 2a minus 2b, or a is equal to minus 2b. One thing. Also, the second one, it was a minus b upon a square minus b square is equal to 2 upon 2. That is equal to 1. Now, okay. You can write it as 1 upon A plus B is equal to 1 or A plus B is equal to 1. A was equal to minus 2B, so minus 2B plus B is equal to 1, which gives you B is equal to minus 1. I got the value for B. That means I can get the value for A as well from here. So A is equal to minus 2 into minus 1, that is equal to 2. We got the value for B and A. What we had to find out in the question, A minus B. A's value was 2 and B was minus 1. That means 3 is the answer. Okay. So we have option B as the answer to the question. Right? Let's move to the next question. Next is question number 69. It says if fx is equal to sine of cos h, this whole expression, then the first derivative of the function at x is equal to 1 is. Easy question, right? You have fx is sine of cos hx x square plus 1 upon this. So let's find out the first derivative. This is given by sine will be converted into cos h x square plus 1 x square plus 2 multiply sine h. So cos h s will be converted into this, sine h into this. Now let's find the derivative of this, x square plus 1 into 1 by x square plus 2. So this derivative will be given by square of the denominator into denominator derivative of the numerator. So x square plus 1 derivative will be 2x plus, sorry, this is minus, not plus. So numerator, that is x square plus 1 into derivative of the denominator. So this will be given by f dash x will be given by cos of cos hx x square plus 1 x square plus 2 into sine h x square plus 1 into x square plus 2. Now, when you will open up this, you will have x square 2x cube plus 4x minus 2x cube minus 2x, right? I think yes. So upon x square plus 2 whole square, this cancels and you will have the derivative as cos of cos h x square plus 1 x square plus 2 multiply sine hx x square plus 1 x square plus 2 multiplied by minus, okay, 2x, 4x minus 2x will give you 2x s square plus 2 whole square. Now we have found the derivative. You have to find out the first derivative when x is equal to 1. This is equal to f dash x. So f dash 1 is equal to cos of sorry, this is not x. Okay, out of just habit, I wrote x over here. So this is going to give me 1 plus 1, 2. 1 plus 1, 2. Multiply sine h. So 2 upon 3 multiply 2 upon 3 square. This is going to give me, so, okay. It was 2. So it's got to be 3. All right. So this is going to give me, this is 2 by 9. Multiply sine h 2 by 3 cos h cos of cos h 2 by 3. So let's check 2 by 9 sine h 2 by 3 cos of cos h 2 by 3. This is option A. So option A stands to be the correct answer. Hope you understood that. Let's move to the next question. Question number 70. If an error of 0.02 square centimeter is found on the surface area of the sphere, whose radius is measured to be 10 centimeter. So here you are given the radius 10 centimeter and error of 0.02 square centimeter is measured on the surface area. Okay, then the approximate error that occurs in the volume of the sphere in cubic centimeters is. Okay, first thing, this error is given on the area, and what is the formula for area of the sphere? It's pi r square. So we are talking about the error. Let's find the first derivative of the area with respect to the radius. So dA by dr is going to give me 4 into 2, that is 8 pi r. dA will be equal to 8 pi r into dr. Now dA is equal to 0.02 is equal to 8 pi into 10. I have to find out dr. This is going to give me 0.02 upon 80 pi as dr. We have to find out the error that occurs in the volume of the sphere. So volume of sphere, you know, this is 4 pi r cube. That means V is equal to 4 pi r cube. Let's find out the derivative. With respect to r, you will have 4 by 3 into 3. 3 will cancel. So 4 pi r square. This is the derivative of the volume with respect to radius. dV is equal to 4 pi r was 10 square, and to dr. dr we calculated, it's 0.02 upon 80 pi. Correct? This is going to give me 4 pi into 100 into 2 upon 100 into 1 upon 80 pi. Pi will cancel, 100, and this is gonna give me 0.1 centimeter cube. This is the error in the volume. Okay, so 0.1, that is option D. Hope you got that. Next question number 71. It says if theta is the angle between the curves y is equal y square is 4x, x squared plus y square is equal to 5, then tangent of theta is equal to. So the two curves are y square is equal to 4x and x square plus y square is equal to 1. Let's find out the derivative with respect to x. So 2y into dy by dx is equal to 4. Here you will have 2x plus 2y dy by dx is equal to 0. This is gonna give me dy by dx is 2 by y. Here dy by dx is equal to minus x upon y. Now for the point of intersection of both of these curves, let's solve them simultaneously. You will have x square plus 4x minus 5 is equal to 0. The point, see, y square is equal to 4x. I'm going to fill over here. You will get x square plus 4x plus 5 is minus 5 is equal to 0. So let's factorize. You will have x plus 5x minus x minus 5 is equal to 0, which will give me the two factors as x plus 5 and x minus 1. So x can have the values as either minus 5 or 1. Now, here x can't be equal to minus 5. Why? Because if x is equal to minus 5, this is going to give me y square is equal to 4x will be minus 20. A square cannot be negative, so I will not take x is equal to minus 5. So therefore, the points of intersection will be for 1. See, when I'm putting, let's solve it here. Y square is equal to 4x. So y square, when I'm putting x is equal to 1, it's going to give me 4. Y is going to give me plus minus 2. So first point of intersection is 1, 2, and the second one is 1, minus 2. Okay. Now, slope of the tangent to the two curves at this point of intersection. Let's say first point is 1 by 2. So the first had the slope as dy by dx was given to be 2 by x. 2 by y, sorry, not x. Right? So this will give me dy by by dx, or the slope is equal to 1. Second curve had the slope as dy by dx is equal to minus x upon y. So this is going to give me minus 1 by 2. This is for the point 1, comma 2. Let's call it for the point 1, comma minus 2. So in this case, dy by dx, which was equal to 2 upon y, is going to give me minus 1. And dy by dx, which is the slope for the second curve, is 1 by 2. Okay. So these are the values for the slopes. Now, tangent of theta mod is equal to, this is equal to 1 m1 minus m2 upon 1 plus m1 into m2. Let's pick up any pair. That's not a problem. You can pick up this pair or this pair. That's perfectly going to give you the same answer. Okay. So if I'm taking m1 as 1 and this as minus 1 by 2, so this is going to give me plus 1 by 2 upon 1 plus 1 into minus 1 by 2. This is going to give me 3 by 2 upon 1 minus 1 by 2. That's 1 by 2 itself. So I'll get 3 as the answer. So tangent of theta mod is option C. Hope you got this. Let's move to the next question, number 72. The local maxima of this function is, okay, fx is equal to minus x minus 2 cube x plus 2 square. Right? For the local maxima, let's find out the first derivative. So f dash x is equal to, this is first function into derivative of second. So x minus 2 cube into 2 into x plus 2 minus, this is plus. First function derivative of second plus second function into derivative of first. Correct? So let's take now x minus 2 square into x plus 2 common. Here you will be left with 2 into x minus 2 plus 3 into x plus 2, which will give you minus x minus 2 square x plus 2, 5x plus 2. Right? Now, for the local maxima or minima, let's put this is equal to 0. So when you will put this is equal to 0, you will have three values for x. X can be either equal to minus 2 or minus 2 by 5 or 2. These are the three possible values for x. So let's see. If you are having this line diagram, here is 2, minus 2 and minus 2 by 5. If you look at the function is decreasing towards the left of minus 2, towards the right of minus 2, and towards the left of minus 2 by 5, it's increasing. This side it's decreasing, and even this side it's decreasing. Okay, therefore, if you look at this, that definitely local maxima is going to occur at minus 2 by 5. So fx has local maxima at x is equal to minus 2 by 5. Right? Therefore, local maxima value is equal to, okay. Equation was x minus 2 cube x plus 2 square. Okay, so this is gonna give me minus of minus 2 by 5 minus 2 cube minus 2 by 5 plus 2 square. That is minus of minus 12 upon 5 cube 8 upon 5 square. That's equal to minus will be plus 12 cube into 8 square into 5 cube into 5 square, that is 12 cube multiply 8 square upon 5 raised to power 5, which is option 12 cube 8 square upon this. Okay, this is option B. Hope you understood this question. then let's move to the next question, number 73. If integral of this function dx is equal to fx into cos of gx plus c, then you have to find out the function f1 by 4 plus g1 by 4 is equal to. Let's write it down. You have to find out the integral of 1 plus cos 8x whole divided by tangent of 2x minus cotangent of 2x dx. That is equal to 1 plus, okay, 1 plus cos 8x can be written as 2 cos square 4x. And here you can write down sine 2x upon cos 2x minus cos 2x upon sine 2x dx. Let's solve it further. You will have 2 cos square 4x sine square 2x minus cos square 2x into sine 2x cos 2x dx. So this is equal to 2 cos square 4x. So now let's multiply the numerator and the denominator with 2. You will have into 2 sine 2x cos 2x upon 2 sine square x 2x minus cos square, here was 2x dx. Now, this is 2 sine 2x cos 2x. This is the formula for sine 4x whole divided by twice, okay, twice into sine square 2x minus cos square 2x. This is the formula for minus cos 4x dx. So, okay, this and this will cancel, 2 and 2 will cancel, and you will be left with minus, I'll take outside, sine 4x into cos 4x dx. Again, the same thing, multiplying the numerator and denominator by 2. You will have minus 1 by 2. So this is the integral of cos sine 8x. 2 sine 4x into cos 4x is sine 8x dx. That is equal to minus 1 by 2 sines integral minus cos 8x upon 8 plus some constant. So that is equal to this. Now this is equivalent to, in the question it is given that this is equivalent to fx into cos of gx plus c. This is equivalent to fx plus cos of gx plus c. So from here, fx multiply, not plus, sorry. This is multiply. So from here, you definitely get that fx is equal to 1 by 16 and gx is 8x, right? And c is c constant. You had to find out f of 1 by 4 plus g of 1 by 4. F of 1 by 4, it's a constant. It's 1 by 16. Let's write this. G of 1 by 4, it's going to give me 8 into 1 by 4, which is 2. So 1 by 16 plus 2 will give me 33 by 16. So this is the answer to the question. Option D is the correct answer. Hope you got that. Let's move to the next question, number 74. Let x is not equal to minus 3 by 5 or 2 by 5 if f of function 2x plus 1 upon 5x plus 3 is equal to x plus 2, then integral of fx dx is equal to. Okay, so I'll start with this function. F of 2x plus 1 upon 5x plus 3 is equal to x plus 2. Now let's put 2x plus 1 upon this is equal to some t. Or you will say 2x plus 1 is equal to 5 into t into x plus 3t, or 5t minus 2 into x is equal to this, or x is equal to 1 minus 3t upon 5t minus 2. Now, okay, so this is the value for x. Therefore, f of t can be written as 1 minus 3t upon 5t minus 2 plus 2. This gives you 1 minus 3t plus 10t minus 4 upon 5t minus 2. This becomes equal to 7t minus 3 upon this. Right? Also, fx was equal to 7x minus 3 upon 5x minus 2. Yeah. So, let's find out the integral of fx dx. This is equal to integral of 7x minus 3 upon 5x minus 2 dx. So, you can write it as 7 into x upon 5x minus 2 dx minus 3 integral of this. This will further be written as 7 by 5. So I can write it like this. Right? This can be written minus 3 into, I'll not touch, it will be as such. So this is equal to 7 by 5 integral of 1 plus 2 upon 5x minus 2 dx minus 3, 1 upon 5x minus 2 dx. That's equal to 7 by 5. So now let's find out integral. Integral of 1 is x plus 2 into 1 by 5 log of 5x minus 2 minus 3 into 1 by 5 log of 5x minus 2 plus the constant c. So this is gonna give me 7 by 5x. And here I'll have a minute. This is gonna give me 14 by 25 log of 5x minus 2 minus 3 by 5 log of 5x minus 2 plus c. 14 by 25 minus 3 by 5. This is going to give me minus, 7 by 5 minus 1 by 25 log of 5x minus 2 plus the constant c. So this is answer to the question. Hope you got that. Let's understand the options. I have, obviously, this is the option C. Option C is the correct answer. Hope you understood this question, right? And then let's move to the next question, number 75. If integral of e raised to power x cos x dx is given by this, and integral of this whole expression is equal to this whole expression, which is quite a long one, but don't worry, when we solve the sum, this is gonna, you will see it pretty easy. It's just like it's saying in the sum to be difficult. Okay, oh, first of all, I'll pick up this one. I'll say let I is equal to integral of cos of log 2x plus 3 upon 3 minus 2x upon 3 minus 2x whole square dx. Now let's put 2x plus 3 upon 3 minus 2x is equal to some t. Let's find out the derivative. You will say dx upon 3 minus 2x whole square is equal to dt upon 12. I hope you remember the formula. So we'll do the denominator square, 3 minus 2x square into denominator, derivative of numerator, minus numerator into derivative of denominator, which is equal to minus over here, minus 2. Okay, which this is multiplied by minus 2. So on solving, this is going to give you dx upon this is equal to dt upon 12. So this integral now will be reduced to 1 by 12 integral of cos of log t dt. So now let's put t is equal to some e raised to power k, which gives you dt is equal to e raised to power k into dk. Therefore, the integral will become 1 by 12 e raised to power k into cos k dk. Okay. Yeah. See, t was e raised to power k, and cos of log of e raised to power k is going to give you k only. Log of e raised to power k is equal to k only. So this is equal to further 1 by 12. Let's find out the integral into e raised to power k upon 2 cos k plus sin k plus the constant. Okay. Now integral is equal to, see, question number 75. If integral of e raised to power x cos x dx is equal to e raised to power x by 2 cos x plus sin x, and this whole integral is equal to some fx upon 24 cos gx plus sin gx plus c, then g of 1 is equal to. Okay, so let's assume this whole expression is equal to some I, right? Next, let's put this thing, 2x plus 3 upon 3 minus 2x is equal to some t. Now let's find out the derivative of with respect to x. You will have the denominator square into, here in the numerator you will have denominator into derivative of numerator minus numerator into derivative of denominator. This is equal to dt by dx. So this will give you 6 minus 4x plus 6 upon 3 minus 2x whole square is equal to dt by dx, which gives you dt upon 12 is equal to dx upon 3 minus 2x whole square. Correct? So the integral I becomes equal to, this integral becomes equal to 1 by 12 integral of cos of log of t dt. Now let's put this t is equal to some e raised to power k. So the derivative dt will be given by e raised to power k into dk. That means the integral I becomes 1 by 12 e raised to power k into cos k dk. So here in the question, it's given e raised to power x, integral of e raised to power x cos x is equal to e raised to power x by 2 cos x plus sin x. So that means there is no need for solving it further. You can directly say it 1 by 12 into e raised to power k upon 2 cos k plus sin k plus the constant c. Okay. So now here you put already that e raised to power k was equal to t. That means e raised to power k is equal to, this was your 2x plus 3 upon 3 minus 2x. This was e raised to power k. Also, you can write down k is equal to log of 2x plus 3 upon 3 minus 2x. So therefore, this whole thing will become 1 by 24 into 2x plus 3, 3 minus 2x multiplied by cos of log of 2x plus 3 upon 3 minus 2x plus sine of log of 2x plus 3 upon 3 minus 2x. This gives you, so now let's compare it with the given equation, this one. Here you have fx is equal to, see this is equal to this expression. So 24, 24 cancels. Let's write down this expression also. So as to have the clear picture, this is equivalent to fx upon 24 cos of g of x sine of g of x plus c. Here was also plus c. So that means this fx is equal to this. Two x plus 3 upon 3 minus 2x, and gx is equal to log of 2x plus 3 upon 3 minus 2x. We had to find out log of 1, sorry, g of 1. So this is equal to log of 5 minus upon minus, not minus, it's 1 only. So this is equal to log of 5, right? Log of 5 is not in the options, but log of f of 1 and log of f of 2, these are in options. Let's find out these ones also. Log of f of 2. So this gives you 2 into 2 plus 3 upon 3 minus 2 into 2, which gives you 7 upon minus 1, that is minus 7. So this is not the answer. Log of f of 1 gives you 2 into 1 plus 3 upon 3 into this. That gives you 5 upon 1. So this is the one. Okay. So this is f1 actually. Okay, this was not a log of f1. This is f1. And log of f of 1 will give you log of 5. That means this is equal to this, or g of 1 is equal to log of f of 1. Hope you understood this. So we have option C as the correct answer. Hope you understood this question. Next is question number 76. Integral 1 limits 1 to 2 x into this whole function is equal to what? Easy question actually. You simply, I'll start with putting 4 minus x square is equal to t. Let's find the derivative. So minus 2x into dx is equal to dt. Or x into dt is equal to minus 1 by 2 x, into dt. So this will integral will become now. Also, let's talk about the limits also. So when x is approaching 1, t will approach. When x is approaching 1, t will approach 3. Similarly, when x is approaching 2, t will approach to 0. Okay, so the limits also will be changed. The limits will be 3 to 0 minus 1 by 2 into root of t dt. So now easy one, minus 1 by 2, 2 by 3 into t raised to power 1 by 2 plus 1. This is going to give me t raised to power 3 by 2. See, t raised to power 1 by 2 integral dt. This is equal to t raised to power this upon this. So this is equal to t raised to power 3 by 2 divided by 3 by 2. That is equal to 2 by 3 into t raised to power 3 by 2. So the limits are 3 to 0. This will give me minus 1 by 2, 0 minus 2 by 3 into 3 raised to power 3 by 2. So this is gonna give me 1 by 3 into 3 raised to power sorry, 3 multiplied by root 3, right? All right. So this is root 3, my answer. Correct. That means we have option A as the answer to this question. Hope you got that. Next question number 77. So if this greatest integer function, it denotes the greatest integer function of x, and limit minus 3 by 2 to 3 by 2, 2x minus 3 dx is equal to k, then k plus 1 by 2 mod is equal to. So you are given that k is equal to minus 3 by 2 to 3 by 2, 2x minus 3 dx. This is limits are 3 by 2 to 3, minus 3 by 2 to 3 by 2, 2x minus 3, because 3 is a constant, so I'll take it outside, dx. Now, you can write it as minus 3 by 2 to minus 1, minus 3 dx, plus minus 1 to minus 1 by 2, minus 2 dx, minus 1 by 2 to 0, minus 1 dx, 0 to 1 by 2, 0 dx, plus integral 1 by 2 to 1, 1 dx, plus 1 to 3 by 2, 2 dx, minus this. Right? So for this for this 2x, I have split this whole integral till here, minus 3 dx. Limits are from minus 3 to 3 by 2. Hope you got this. So next, let's find out the integral. Now it's very easy. We have done the most problematic thing of the sum. So this is minus 3 and the limits x minus 3 by 2 to minus 1 plus, actually minus 2 x minus 1 by 2 minus 1 x minus 1 by 2 to 0, and this has got to be 0. One by 2 to 1 plus 2, 1, 3 by 2 plus 3 minus 3 by 2 to 3 by 2. So now this can be written as minus 3 minus 1 plus 3 by 2. This is going to give me 1 by 2 minus 2 minus 1 by 2 plus 1 is going to give me 1 by 2 again, minus 0 plus 1 by 2, that is equal to 1 by 2 plus 0, 1 minus 1 by 2 plus 2, 3 by 2 minus 1, this is this, plus 3. Sorry, it was minus 3, not plus. I hope I have not, yes, it's okay. So this is 3 by 2, that's going to give me a 0 again. Sorry, 3 by 2 plus 3 by 2, this is going to give me 3. All right, so this is minus 3 by 2, minus 1 by 2, plus, wait, minus 1 by 2 is this, plus 0. Here was plus 1 by 2, plus 1 minus 9. This is, these two will cancel and this will cancel with this. You will be having minus 3 by 2 minus 9. So this is gonna give me minus 18, minus 21.2. Okay. So next we have to find out mod of k plus 1 by 2. This was all equal to k. Mod of k plus 1 by 2, that is minus this. This is gonna give me minus 10 or 10 will be the answer. Right? Option C is the correct answer. Hope you understood this question. Let's move to the next question then. Question number 78. Differential equation corresponding to the family of curves given by this, where A and B are arbitrary constants is. Let's write down the curve ax square plus by square is equal to 1. Let's find out the derivative 2ax plus 2b into 2by into y dash, that is the first derivative of y, is equal to 0. This gives me y dash is equal to minus ax. Yeah. Or y dash upon x is equal to minus a upon b. So let's find out the derivative, second derivative now with respect to x. You will have it square of the denominator into denominator and the derivative of the numerator. Now this is going to give me y square plus y into y second derivative minus y into this. This is equal to 0. So this gives me xy y double dash. Let's write x square y square plus x square y double dash minus this is equal to 0. This will give me xy into y double dash plus x into y square minus y dash is equal to 0, right? Sorry, here was x and that is what I was looking for, and here is got to be x. Okay, so now this matches x y double dash plus x y square minus y dash. This is the answer to the question, and this matches with option B. Hope you got that. Let's move to the next question then. Question number 79. For the differential equation, this order is 2 and degree is 3. Like, what is the order and degree basically for this question? All right. So you have the root of the second derivative of y with respect to x is equal to cube root of y into dy by dx plus x into sine dy by dx whole square. So this can be written as dy by dx raised to power 1 by 2 is equal to y into dy by dx plus x sine dy by dx whole raised to power 2 by 3. So let's take the power because here is 2 and here is 3. The LCM of 2 and 3 is 6. So raising the power by 6 on both the sides. Raising to the power of LCM of 2 and 3, that is equal to 6 on both sides. Okay. So this is gonna give me dy by dx is raised to the power 3 is equal to y dy by dx x sine dy by dx raised to power 3 by 2 by 3 into 6. It's gonna give me 4. So looking at this, what is the order? See, sorry, here was a second degree. Okay. So order of this differential equation is equal to 2 and degree is not defined. Why? Because this differential equation is not a polynomial in dy by dx. Okay. Not a polynomial in dy by dx. Therefore, the degree is not defined for this differential equation. That means the order is 2 and degree is not defined, and option D stands to be the correct answer. Hope you got this. Then let's move to the last question of this paper, mathematics paper. It says the general solution for the differential equation is. Okay, I'll start from here only. This is a differential equation. I know this. So the general equation, so that means I have to find out integral on both the sides. Let's put the integral on both the sides. You will have here, let's split it up. I'll take x, okay, x, y plus, I'll solve it here. Xy plus x minus 2y minus 2 upon xy minus 2x plus y minus 2. So I'll take x common. You will have y plus 1 minus 2, y plus 1 whole divided by y minus 2, y minus 2. So you have x minus 2, y plus 1, y minus 2, x plus 1. So these are the two factors. Okay. So this can be written as, I'll rewrite this one. Okay, I'll find out this can be written as, give me a minute. Dy by dx is equal to x minus 2 into y plus 1 upon y minus 2 into x plus 1, or y minus 2 upon y plus 1 dy is equal to x minus 2 upon x plus 1 dx. Okay, now I have segregated the terms with the y on the y d with dy, and I have segregated the terms with x with along with dx. Now let's take the integral on both sides. It's easier to solve this way. Okay, I'm taking the integral on both sides. So this can be written as integral of y upon, you can write it as like this, y plus 1 minus 3 upon y plus 1 dy is equal to integral of x plus 1 minus 3 upon x plus 1 dx. This gives you 1 upon y plus 1 minus 3. I'll take outside, y plus 1 dy dy. Sorry, this is 1 only. This is equal to 1 into dx minus 3, 1 upon x dx. This is going to give me y minus 3 log of y plus 1 is equal to x minus 3 log of x plus 1 plus c. So this is actually equal to x minus y plus 3 log y plus 1 minus 3 log x plus 1 plus c, or this is equal to c. So x minus y plus 3 log y plus 1 upon x plus 1 is equal to c. This is the answer to the question. So we have option D as the correct answer. Hope you understood this. So students, with this, we have completed all the 80 questions of this mathematical paper. But before leaving this paper, do visit our website www.examsnet.com for your better preparation. There you will find a variety of entrance exam question papers with their solutions. So best of luck. Go ahead and explore the website. You can also download our app. The link is available in the description box. So students, keep shining, keep rising high. Best of luck for your exam. That's all for this paper. Bye.